Okay, let's talk about iso-hypothermal plasmonic preservation. It's probably one of the most scientific dorky names we have across all of our hair restoration. And pretty much what this means is that we're going to cool down the grafts to a nice constant temperature that does not change. And instead of bathing them in artificial tissue or liquids, we're going to bathe them in your body's own plasma. Now, why do we do this? It's all about graft preservation while they're outside the body and making sure these grafts are nourished. When we take out these grafts, remember there's no blood supply to them anymore. There's nothing providing them with good nutrient supply. When we put them back in the scalp, it's actually some time before that revascularization process takes place, 5 to 10 days. And they're kind of being supplied by diffusion of nutrients within the plasma. So we take these grafts out, we can put them on the table, and they're pretty much going to die. One of the easiest things to do is to cool them down. A lot of people use ice packs for cooling down the grafts. The problems with ice packs is that the temperature fluctuates in the ice pack. And if it drops below freezing or a little bit below that, ice crystals can form within the cells of the graft itself, and it can cause those cells to rupture. And we definitely don't want that happening within the oil gland or the stem cells around the follicle. When it thaws, that graft can reach higher temperatures, that its metabolism will kick back up and it'll need more energy. And while it's outside the body, you really want to knock that metabolic need down that graft. So ice in general may not be the best way to hold constant temperatures of grafts. So we do something iso-hypothermal, means constant low temperature cooling, where the grafts are held at 4 degrees Celsius on one or two different ways, either within a flat cooling plate that maintains the temperature in the graft chamber, or within a chamber itself where the entire graft is in a cooled box where it stays at a constant temperature throughout the entire time. That is reducing the metabolic need of the graft. Now, to supply the metabolic need of the graft, there are a couple of solutions available on the market. One's ATP. That's the energy molecule involved with essentially cell metabolism. You can buy that, or some people don't even bother with that. They'll just do normal saline or hypothermal saline, whatever it is. They won't have those. One of the best ways you can actually preserve the grafts is actually within the fluids it's normally bathing in within your body, the plasma. And with real easy techniques to draw your blood to extract the plasma, we can actually bathe these grafts in your plasma while they're outside the body. And we found that there's actually additional benefits, such as early graft growth, your graft take. They're also associated with plasma, not just supporting the metabolic needs of the grafts while outside the body. So a combination of iso-hypothermal, constant cooling, and plasmonic preservation within your plasma is one of the ultimate ways to preserve the grafts long term. Now, in very efficient procedures of low graft counts, 2,000 to 3,000 grafts, you probably don't need to deploy these techniques. You can probably get through the procedure nice and efficiently with an efficient team. In our office, we're crossing the 6,000 graft mark, and these grafts are outside the body for several hours. We want to do everything possible to preserve them such that we don't lose the grafts when outside the body, because why would we have extracted them, have them die, and implant them when they're dead? There's no purpose. That's the best technique we have today is iso-hypothermal plasmonic preservation, and it's recommended for high graft counts.